Morning, students. We will continue the concept of integration type. I taught you two types at the end. That was 1 upon, sorry, px plus q upon ax square plus bx plus c, which is a quadratic one, and second I is equal to px plus q upon over root ax square plus bx plus c. You remember that. These two, and you know that one question I did in the last class. Today I will tell you one more question, but let me tell you that your job most important here, that you should know your duty to do the questions. All questions are of the same kind. So I'm taking here question number, suppose I'm telling you 19th one. Question 19 says 6x plus 7 upon over root, this is x minus 5 and x minus 4. You should not surprise, student, because if you will focus to the denominator, that if I'll multiply these two, it will be x square minus 5x minus 4x minus 9x plus 5 4 20. So definitely question, this is a suitable question, and it is a linear upon in square root, it's a quadratic one. So this portion may be with the square root, maybe without the square root. The method is very same, and I taught you the method that the linear part will be taken as a into d by dx into quadratic part plus b. This time you don't need to take the under root sign. Then after 6x plus 7, a into d by dx of that is 2x minus 9 plus b, and this will be given 1. Now I multiply to a in the bracket, 2ax minus 9a plus b, and this is 6x plus 7, and I will compare now. The coefficient of x is 2a and coefficient of x is 6. So a will be 3, and another comparing of the constant term, minus 9a plus b will be 7. Your a equal to 3, 3 9s are 27, plus b is equal to 7, so b is equal to 34. You have got a and b. So guys, now you will put both of the values in the equation 1. So 1 will change as d 6x plus 7 equal to a, the meaning of a is a 3 into 2x minus 9 plus b is equal to 34. This is the thing. Now 6x plus 7, you have got a replacement, and this proper particular replacement you will put in a question. So I will change as 3 into 2x minus 9 plus 34 upon that whole question. What was the question? X square minus 9x plus 20. So question has been changed like that. And what is the next duty? Only to separate the term. So I will be, when this by this will be written, 3 is a constant value, can be written outside, 2x minus 9 upon square root x square minus 9x plus 20 dx plus, and separate to integration with this also, 34 upon, this is x square minus 9x plus 20 dx. And this time is very easy, because now you will take t now, x square minus 9x plus 20 equal to t. The differentiation of that is 2x minus 9 dx is equal to dt. Automatically 2x minus 9 is waiting for you in numerator side. I is equal to 3 into this, and this will replace by dt upon t, plus that 34 I'll take it out, and only 1 by that whole will be turned in a complete square, because this section will be familiar section, which is 1 upon, you have to turn to this quadratic term in a complete square term, and you can use a formula. So I am going to use its the so-called method is a square minus 2a, b is a half of that, 9 by 2, plus 81 by 4, b square, adding and subtracting, and plus 20 is same, and dx. So I is equal to 3, that 1 by root t is a 2t after integration, plus 34, that 1 upon, the denominator side is first 3 term will be a minus b whole square, and these two will be, it's a minus 81 by 4, this is a 20. After taking LCM, 80 and 81 is a minus 1 by 4, meaning minus half square. One can do it very easily, that after taking LCM of these two terms, we'll get a minus 1 by 4, but can be written minus half square, and you can use the formula 1 upon x square minus a square. So what the formula is, you remember that 1 upon over root x square minus a square, dx is a log x plus same. Log x plus same. This is the formula, guys, you can use it. So I is equal to 3 to the 6 t. It's your duty to put the value of t. You consider that one. And 34, now use the formula log x plus same. So what is the same? X minus 9 by 2 square minus 1 by 2 whole square. And what to do, student, further this? You can drop your answer right here or put your value t, it's necessary, and log this is same, it must be same, plus this portion came from here, this portion came from here, this came from here. So you can write to whole this instead of these term is equal to this term. So this is the next, this may be the next step. I'm leaving that. I'm leaving on you only. You can write that under root term equal to this. This will be suitable. So this is your answer. So hope, student, you have got the method properly, and that is very important for one and all, for exam also. So please do this. Please do the practice. And now I'm moving on the next concept. Next concept. Look at what it says. Now in the next, it's very important topic I'm going to discuss. This is a partial fraction. As far as the exam is concerned, I'm very sure that one question may come from this exercise. So first of all, we'll study partial fraction. What is a partial fraction? Look at, I put an example, very important example this is. Suppose x plus 1 and x plus 2. This is a algebraic fraction. 1 upon, no matter 1 except 1, maybe any number there, any polynomial there. So this is the algebraic fraction. You know, and denominator we have a 2 factor, x plus 1, x plus 2. If without any rule, I write 1 upon x plus 1 and 1 upon x plus 2, what do you think? Is it right? No, it is not right. Because after taking LCM, I will not get same term. No, x plus 2 plus x plus 1 will be 2x plus 3. But it is not same. So, you know, it seems correct, but it is not correct. When it will be correct? Suppose I write minus 1. Meaning that 1 and that minus 1. Now take an LCM. X plus 2, you know, minus x minus 1 upon x plus 1 and x plus 2. These two cancel, 2 and 1, 1. Meaning in the numerator, I'll have a 1. And this is very same. It means that the thing, denominator is x plus 1 and x plus 2 was exactly correct. Because after taking LCM, denominator will be x plus 1, x plus 2. But the numerator part is actually, you know, that you cannot take without any procedure or method. By prediction, it is very tough. Right now, I used the prediction method. I used here 1 and minus 1. These two numbers very important to take. How we can take so that after taking LCM, I'll get the same answer. If you supposed to have this question, I tell you that I also cannot do this by prediction method. I hope you are getting me. Actually, this was very simple term which I actually can be balanced. But if x or something, x plus 1 it is coming, x minus 1 is suppose coming or some else coming, it's not so easy to separate the denominator. What is the main thing? You know, the partial fraction meaning you are going to separate the denominator in two different parts, two different sections with plus or minus sign. I know that if I separate in two terms, x plus 1 will be here, x plus 2 will be here, but I don't know what these two will be there. This time it was 1, it is a -1. This was a simple prediction. I used a trial and error method and I got answer 1 and -1. But instead of that, if I supposed to have x minus 1, if you will tell me that break it now into part, resolve into the partial fraction, I am unable to do with the prediction method. Actually, we have to follow some proper method, and that method called partial fraction, in which denominator separates different values, different numbers, different terms. So that is important. So it follows some situations, and one by one I would tell you that first of all, proper fraction and improper fraction we discuss, proper and improper. So let me explain one thing, that partial fraction is a method only used with proper fraction. And what is proper fraction? Look at, I tell you. Can you see that? Can you see the fraction? Can you see the fraction? Look at, it is x plus 1. The numerator's power is 1. And when you will multiply them, when you will multiply the denominators, now x square plus 5x plus 6 will be there. When the denominator having a greater power than the numerator, it is called a proper fraction. And these two are proper, same actually. These are proper fraction. But against it, if you have both same power, or the numerator power is when the power of the numerator is greater than the denominator, in both cases we say that this is an improper fraction. When powers are equal or the numerator power is greater than the denominator, in both cases it is called an improper fraction, and this is called a proper fraction. So okay, whenever the proper fraction will be coming, you can resolve into the partial fraction, but whenever the improper fraction will be coming, you cannot resolve them into partial fraction. So what I mean to say, whenever you are having this kind of a question, first of all, you will divide to this by this and you will turn to this fraction into the proper fraction. Now I will teach you that this term is coming with you, suppose x cube plus x square plus 5x plus 7, and suppose this x square plus 5x plus 1. Suppose this is a question with you. So what you will do? And suppose this is a question with you. Suppose this is a question with you. What you will do? Actually, look, this is x into x, x square. This is x cube. One should assure that it is not proper. It is improper fraction. So I will divide to this by this. I will change to this into the proper fraction. How I? After multiplying to the denominator, one should know that it is coming x square plus 5x plus 10. Sorry, 6. Now I will divide to this by this. Look at what I am doing. I am turning to that improper fraction in the proper fraction. So how we can do? X square plus 5x plus 6. You know it, x will be coming here, x cube plus 5x square plus 6x minus cancelling, 4x square minus x plus 7. You know that till when we have to divide? We have to you know that we have to divide the procedure till the power of the remainder should less than the power of the divisor. You know this 2 and this is 2, meaning yet to divide. When this power gonna be less than the divisor power, meaning the division is over. So this is yet to divide. The minus 4 and 1. This is definitely minus 4. Minus 4x square minus 20x minus 24. And now student, you can understand that this is gonna be 19x and this is gonna be 34. Now this is x have a 1 power, the divisor have a 2 power, meaning the division is over. So how to write? That was improper. So I will turn. How we can turn? You know that mixed fraction. First we write quotient plus remainder upon divisor. So that only the method. Now can you see this part? This has been changed in the proper fraction. No, it's a power 1, it's a power 2. And this is a part of the answer. Till end it will be same. You don't worry. You just have to learn whenever the improper fraction is coming, you have to divide. And then after dividing, you will write to the whole method in a mixed fraction like that. When you will see the next part, you will observe that this has changed in a proper fraction. Now you will do the work. Still, lots of questions may be in your mind that actually what we are doing. Actually what we're doing, when this question is coming in integration sign, so you first attempt, in first instant, you should know that this is improper one. So you have to divide, and now question has been changed like that. Now integration of x is integration of 4 but integration of this is yet to do. And that only I will tell you that how we can make this question. So look at student, till now I have taught you what is proper fraction and what is improper fraction. And whenever the improper fraction will be coming, what you will do? You will turn this in the proper fraction by dividing. Now, again I tell you the meaning of partial fraction. What was the question? That x, suppose x plus 1 and x plus 5 is coming here. And I want to resolve into the partial fraction. And what is the meaning of partial fraction? You will separate to the denominator in two parts with different numerator. But I don't know what the numerator is. So student, let me explain one thing, that it is assured that first denominator part is x plus 1, second denominator part is x plus 5, but I don't know what the proper numerator. So I have to find this and this, and that is a question mark. So that in symbolic form, I tell you that first pattern, first type, when in denominator, look at, when denominator is the factor of the, when factors of denominator are linear and without repeating. Look at, this is the concept, and what it's meaning. Suppose I am writing 1 there, except 1, anything may be there, and look at the denominator. In symbolic form I am using that. 1 upon x plus a, x plus b. Can you observe the sentence? When factors, meaning these are factors, are of the denominator, in denominator, linear. What is the meaning of linear? Can you see x to the power 1, x to the power 1? Don't multiply them, and then it will be quadratic. But what I have written, factors are linear. These two are linear factor. Because x to the power 1, x to the power 1, they call a linear factor. And without repeating, I tell you that if you supposed to have some power on any factor, it is a repeating. Suppose you have a 2, it is a repeating. But what I have told here in the first method, that this is a without repeating. Guys, it is a without repeating, meaning both have a linear factor and both definitely have no power, meaning 1 power. So this is called linear as well as without repeating. When 2 or more factor may come x plus a, x plus b, x plus c may be there. But in whole cases it is called a linear factor without repeating factor. Okay, so suppose question is coming like that. So what you will do? I am telling you how to resolve into the partial fraction. So I already have taught you that when I will separate them in 2 parts, its numerator is questioning that what is the numerator. So I'll take it as a capital A and it's capital B. So it is still hide. Capital A and capital B is our requirement. What is the answer of A and B, so that these two are balanced. So you know that the whole method actually focused on the numerators, because denominator is the same, definitely same. So now we will try to find how we can find A and B. Sometimes student thinks why I use a plus sign, why I didn't use a minus sign. I tell you, if my minus is to become, no matter, B will be negative. Suppose B is minus 2, so it automatically will be minus sign. So don't worry about that, always take a plus sign. If minus is coming in some cases, definitely B will be negative. Suppose A is a 5, okay, B is minus 2, okay, so whole will be 5 upon x plus A minus 2 upon x plus B, like that. So you don't worry about that. A and B may be positive, may be negative, it will definitely balance itself. So this is the thing you have to remember only. Remember that whenever the factors is coming in denominator, whenever it follows this one, you have to separate them like that. Now I am telling you that how we can find A and B by taking one question. Look at. So what to do? I'm putting one question for you. Example number 11. Look at example number 11. So page number 318. 318. Okay. I equal to 1 upon x plus 1 x plus 2 dx. This is a question. So this is a question. Don't worry about that integration. See the question. 1 upon this and this. And this is actually pulling our attention towards the partial fraction because these two are the factors and it's looking like that, following that one. So how you will start the question? You write take 1 upon x plus 1 x plus 2. Write only without integration and start with capital A upon first factor, capital B upon second factor. And you should think that it is a proper fraction. Why? Because x into x is going to be x square. So power of the denominator is a 2 and there is no x in the numerator. So power of x is 0. So definitely power of the denominator is more than the power of the numerator. So whole is called a proper fraction. Second thing, denominators have already factors. If it would not be factor, you have to do the factorization of the denominator because in partial fraction, the denominator of having factors must necessary. Okay. So a upon and b upon have written. So this is the thing. I need a and b. So what to do? I take LCM. And this is a so-called method. Now you have to use same method in all the questions. Whenever you write like that, you have to take the LCM. Okay, I'll write. So along with a, it is coming x plus 2. And along with b, it is coming x plus 1. And what it is same? 1 upon x plus 1 and x plus 2. So what you will do? These two will be cancelled. Always. Look it is equal to sign. So denominators will be cancelling. So what remaining? So 1 equal to a into x plus 2 and b into x plus 1. What you will do now? That is a key step now. After it, we will find capital A and capital B. So we have a two method. You can multiply to A and B and you can compare both sides. You know the comparing. In the case px plus q upon ax square plus bx plus c linear upon quadratic, I taught you how we can find capital and capital B just by multiplying and comparing both sides. Same as this one. But I tell you one more method which is actually fruitful and useful rather than the previous one. And what is this? Look at. This is a linear factor. This is also a linear factor. And try to hear me. Whenever the linear factor is coming with you please use the value putting method. That is not a specific method just by teacher, by me. It is using the words value putting method. And what is value putting method? Look at. Put here such a value of x so that we will get whole term 0. Put here any value of x so that it gets 0. And you know that how we can. Put x equal to minus 2. Put x equal to minus 2 both sides. So it is a 1. Without x, 1 will be 1. When you will put x equal to minus 2 plus 2 will be 0. But here, surprise, minus 2 plus 1 is a minus 1. You know, 1 equal to b into minus 1 whole b equal to minus 1. You got a value of b. Very easy. So as you make this 0, as you have made this 0, you also can make it 0. So how? Just put again x equal to what? Minus 1. Put x equal to minus 1. So what you will get? 1 equal to a minus 1 plus 2 is a 1. And it is a 0. So a equal to 1. Wow. This is very easy. So it's a value putting method is one of the easiest method and this only applied for linear factors. Whenever the linear factor is coming, go through this and get one value or two value or as many linear factor with you, definitely you will get the same a constant value you will get. Like two linear factor we had, two values we got. That's very fact. Okay. Now put A and B in a question like what the question will be. So 1 upon x plus 1 x plus 2 by 1. Try to understand by 1. You got a 1 upon x plus 1. B is equal to minus 1. So look at minus 1. This is the thing. So put A and B. I tell you one thing that plus and minus ultimately will be minus. So you should write minus 1. So I taught you initially, use a plus sign. If it is to be minus, B will be negative. And that same came here. Okay. Now your question was I equal to integration. This one. So So integrate both sides. Definitely this value is equal to this one. This will be placed here. So I will be, this value has been changed by this one, 1 upon x plus 1 and 1 upon x plus 2 and dx. Now you will understand that I will integrate both the term x plus 1 dx and x plus 2 dx and integrate both. This is log x plus 1, 1 by linear x, 1 by x log x, 1 by x plus 1 log x plus 1, and it is same log x plus 2 plus c, and that's an answer. You can also write log m minus log n equal to log m upon n, and that's an answer. So hope you've got the method, student. In the next class now I will tell you that how question can be done, what different kind of question will be coming. So we have three type, first we have seen. So we have three type, total three type in this exercise. We will do one by one. Thank you.